Hi, today we're talking about the roller coasters, how physics affect it, and how we can see that in every average day in our lives. First, we're talking about the energy and how it affects the roller coaster. The two types of energy we're going to talk is first potential energy, which is dependent of the mass and weight of the object, in this case the roller coaster, the wagon of the roller coaster, and the kinetic energy. Second, we're going to talk about the changes in velocity and speed, which is the acceleration. Then, and how the force consists of changes in speed of the wagon and the passengers and the length of the road. And finally, we're going to talk about Newton's laws, which the first one is how it occurs in the passengers and the wagons. And the second, we are going to talk about the behavior of the objects.
Hey everyone, as you know, a roller coaster ride is a thrilling experience, but how about energy and how it works? So the roller coaster, when it starts, it has potential energy, which is the energy of vertical position, and is dependent upon the mass of the object and the height of the object. As the cars descend the first drop, they lose much of the potential energy in accord with their loss of weight. The cars subsequently gain kinetic energy. What is kinetic energy? Well, it is the energy of the motion. It's dependent upon the mass of the object and the speed of the object. So, we know what happens when it goes like this, and like this. But as the ride continues, the train of the cars are continuously losing and gaining weight. So each gaining weight corresponds to the loss of speed as kinetic energy due to speed, and is transformed into potential energy due to height. So this is the relationship is often stated in the form of the following mathematical equation, which I will show right now. So it corresponds to the initial, and final. So we can know how the roller coaster works. And well, thank you. That's all about energy.
In roller coasters, we can identify physical factors as energy, the Newton's laws, and the changes of velocity and speed. Therefore, this is how velocity and speed works in the roller coasters. The velocity of the roller coaster's wagon changes all the time. It can increase or decrease since the change of direction of the roller coasters are also constant. Any change that occurs in velocity is called acceleration. The force exerted by the roller coasters is related to the changes of speed of the wagon and therefore of the passengers and the length of the road. When we see horizontal stretches, the speed does not change because there is no acceleration and the net force is zero. In the horizontal curves and falls, there is acceleration and a constant change of speed and velocity.
Now we are going to talk about Newton's laws. The first law of motion refers that an object will not move unless force is applied to it. In the case of a roller coaster, the train will be stopped at the station. Once loaded, the operator activates a system of friction wheels under the train that divert it forward, until it leaves the station and hooks up with the train. The third law of motion holds that for every action there is an equal and opposite reaction. This law includes two objects. An example that we will be able to verify will be the train and the passengers on the roller coaster. As soon as the train begins the descent due to the thrust, we will notice that our body will completely stuck to the seat until in the final stretch in the braking zone, the train is stopped by the action of the brakes and our bodies still tend to go forward.
Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased.